In the last video, we said that if a particle is moving in a uniform magnetic field and it's moving perpendicular to that magnetic field, then it is going to go in a circle. So that was this picture. We came up with this relationship that handles all the quantities involved. All right, I want to just add a little addendum to this, and to do so I want to actually look at this picture from the side, and I've drawn it right here. So if you're looking at this from the side, in this picture the magnetic field is going into the screen. So if you're looking at it on the side, the magnetic field would be going to your left, right? And you'd be looking at the particle going in a circle sort of on edge. So it would just be, it's kind of coming towards you down and then going up the back and then down the front and up the back and all that. So it's going in a circle and we're looking at it on edge, right? Okay, so an important thing was that we had to assume that the object was moving perpendicular to begin with. But what if the object, instead of being always perpendicular to the magnetic field, what if it started out with a little bit of component of its motion that's parallel to the field? So what will happen then? Let me redraw this picture. Okay, so here we go. So here's the magnetic field and here's the particle. Instead of moving perpendicular, it's moving with a little bit of component anyway, a little bit component in the same direction as the magnetic field. Well, yeah, so what's going to happen is we can break this down. We can break its velocity down into the part that is perpendicular and the part that is vertical. Now the part that's perpendicular is going to behave as we spoke about here. It's going to be turning. So this part will turn, and so it'll go in a circle again, sort of down the front and then up the back, down the front, up the back. But the whole time we're also going to have this to the left velocity. And what's the magnetic field going to do to that part of the motion, that part of the velocity? Well, the force on just that part is going to be 0 because the angle is 0 and sine of 0 is 0. So actually the magnetic field is not going to, the force that it exerts is not going to affect at all this to the left motion. So it's going to go in a circle, but at the same time it's still going to be moving this way. That part won't change. In fact, that motion will just be constant velocity. And so what you'll end up getting is a helix, which I'm not drawing very well, but you get the idea. So it's going to be going in a circle. It's going to just spiral while moving to the left. So kind of like tracing out a slinky. All right, so a helical path will be the trajectory. So a circle if you are just going perpendicular, but now if you're not going perfectly perpendicular, you'll go in a helix. And again, the reason is that component of velocity that's parallel to the magnetic field just won't ever change. It won't go away, so you'll just have to keep moving this way while you do the circle thing. All right, so I wanted to finish up that storyline with that. So helixes are also possible trajectories when you're in a uniform magnetic field. One other thing actually that I want to talk about is again related to this. Let me draw again a magnetic field going into the screen. Okay, and this time what I want to talk about is an object, so a uniform magnetic field is an object that is coming from outside and going into the magnetic field. So out here there is no or very little magnetic field, so no force on it. So this particle is just going to be going on constant speed, and then it's going to go into the region where there is a magnetic field, a uniform magnetic field. Now if it's coming in, it's coming in perpendicular, so it's going to have a circular trajectory at this point. So it's going to go in a circle of a certain radius that is based on that relationship we talked about, right? So it's going to go into a circle, but of course by the time it gets to the top of the circle, it's now directly above the bottom of the circle, which is when it entered this field. So now it's coming out of the field. Okay, so this is what will happen if you if there's like a a nice straight boundary, and suddenly you go from no field to field. You're going to go in a semicircle, and then come back out again.